So we are on a new chapter. And as you can see, we're going to do two things. Tomorrow, or actually, I guess I split the homework into 2 days, right? I don't know why I did that, but that's what I did. So whenever, Thursday, Friday, I guess, we're going to do, I think, 3 other ones, at least 2 other ones besides this, that they all are kind of similar to each other, all right? It's the same, it kind of has the same vibe. But we're going to just do 2 of them today. I think there's 5 altogether. I can't remember off the top of my head. Anyway, this is what we're going to do. So we're actually going to use, I think I'm going to spend almost all the time on this other program that I have. So let me get that for you. So I'll click that, click off of that. There we go. That's our program we're going to use. Here, it's called GeoGebra. Oh, you showed it. I have shown it to you? I think I just told you. I didn't really do anything with it, though, did I? You did a little bit. Just a little bit. Okay, well, I'll show you a lot today. Now, this is a program that I only use. I've started. Thank you. This is a program that I don't use all that frequently. I'll use it for this stuff right here. There may possibly be another time later on where I might use it. So it's not something that I use every single day, so I might be a little bit slow on doing some things. But I was practicing a little bit earlier, so I think I've kind of got it down now. All right, so let's talk about the first one, which is called Orthocenter. Circumcenter. Before I do Circumcenter, though, we got to talk about the definition of something, and it's called, let's see. Now, there's a few things that I know I can do. I just forget how to do it. I could write on here, and I just forget how to do that. There is a way to write. Is it text? Maybe? I don't know. Let's see. Circumcenter. All right. Okay. Yeah, there we go. Look at that. All right. So the first thing we're going to talk about, well, it's the circumcenter. You know what? I should have done this. Let's change that. Let's change it to perpendicular. If I could type perpendicular bisector. All right, so that's what we're going to talk about right now. All right, so what in the world is perpendicular bisector? Well, it's kind of in the name. All right, so we've got a segment. Hunter, I would advise you to stay awake for this because this is not just a real simple little easy lesson. I mean, it is kind of, but anyway, you're going to need to watch. So what I'm going to do is I'm going to do a perpendicular bisector. So I'm going to use a segment. All right, so this is not a straight line. If I hit the Alt key, I think it stays horizontal. Click it. All right, so there's a line segment right there. Okay, what do I have to do to that line segment? I got to do 2 things to it. What am I going to do? I'm going to draw another line or a line segment that's what? Perpendicular to it, but it's perpendicular to it where? At the midpoint, right? Because of bisector. Bisector, it splits this thing in half. Make sense? So let's do that. Let's put a midpoint in here. I've got a little thing. Just got to remember where all this stuff is. Do you see where it? Oh, right there. Midpoint. So I can click on midpoint, and what I can do is just click on this line. I don't even have to click where in the middle. I can click over here, and what it does automatically puts a point right at the midpoint. So that's kind of convenient. All right, so I don't have to guess. Excuse me, I know. Oh my, I'm getting choked up. I'm so excited about this. Oh. All right, so that's the midpoint. Now, that's part of it. That's the bisector part. What do I have to do now? Draw a line that's what? Perpendicular, and it goes through point C, which is the midpoint, okay? And I happen to have, well, actually, I'm just going to do another line segment. I'm going to click this point right here. Now, look, I need to make this perpendicular. On my computer, if I hit the Alt key, it straightens up and it makes it perpendicular. Click it, and there we go. So now that is a perpendicular bisector. I could have that go all the way through if I wanted to. Oh, because you started up top? Yeah, you could do that. That's fine. All right. So this line, or this line segment, could extend and make a line. This AB, though, cannot be a line because I can only bisect a segment, right? It can't bisect a whole line. You agreed with that? Now, here's what's kind of interesting about a perpendicular bisector. I didn't practice this. There is a way that I can tell what that angle is right there. Let me just see. We got a couple minutes. Do you mind? Angle with given side, angle measure. So I think if I click, is it this and then this? Ah, there it goes. Check that out. I did. I figured something out for once. It even tells you 90 degrees. It even puts the box right there. All right, which is kind of cool. Let's move that C. Let's move that C to there. All right, so that's perpendicular. Would you agree? And it's a bisector. I think there's a way, distance or length. Let me do this. Let me click on that. No, that just tells me the whole length of AB. Oops. All right, I got to quit fooling around. Let's move that C over here. All right, there is, anyway, just believe me, AC does equal BC. Would you agree with me on that? Yeah, sure looks like it, and it does. So what I'm going to do now is something that's going to help us out with the circumcenter. All right, this isn't exactly circumcenter right now, but this leads us up to circumcenter. Everybody with me so far? All right, so what I'm going to do is I'm going to draw a segment from point A to point D. Now, take a wild guess. If I drew a segment from point B, right, the other end point, to the top of that perpendicular bisector, what do you think could possibly be true about this side and this side right here? Yeah, they are going to be congruent, AD and BD. Again, I have a little thing right here. If I click distance or length, if I click this, that's 8.2. Hopefully this will work. Click that. Yep, it's 8.2. All right, let's just put this out there like that. All right, that's pretty cool. Now, are they only equal to each other because of, I made that initial line segment a certain length or something like that? No, I could have made that any length at all right? And if any point on this perpendicular bisector, I didn't have to go up to the top of it. I could have picked any point along this little line segment right here, or this line. I could have kept this thing going down like this, right? I could have made it a line and it kept on going down and down. Any point on this perpendicular bisector is going to be equidistant from the endpoints of that perpendicular bisector. You watching? Okay. Some of you aren't. So watch this. I'm going to put a point anywhere on that perpendicular bisector. Okay, put it right here. Now, let's try this again. Let's go from A to E, and let's go from B to E. What do you think is going to be true about AE and BE? They should be congruent as well. Now, are they going to both equal 8.2? No. All right, but if I click on that, that's 6.4. What do you think this one's going to be? 6.4. There you go. All right, and let's just move this right there. Now, what's cool about this program is this, right? I could take this E and I can move it around. So it doesn't matter where. It doesn't matter where on that perpendicular bisector. Look at it. They all stay the same, don't they? So those two segments are always going to be equal to each other. So that's kind of cool. Everybody got that? All right, so that's kind of neat. So now we are going to do something like this with the circumcenter. All right, so now let's deal with circumcenter. We deal with circumcenter when we deal with a triangle. So I'm going to draw a triangle. You could draw any type of triangle. It could be an acute, it could be right, it could be obtuse. All right, doesn't matter. I'll probably just start off, and I'll show you why it doesn't matter in a little bit after we're done all this stuff. So let's go to there. All right, so there's a nice triangle. I can move this around and change the shape of it, right? I can make it obtuse. I could kind of guess and make it a right triangle. I could make it acute. Let's just start off with an acute triangle. Is that all right? So what I'm going to do, we talked about perpendicular bisector, right? So what I'm going to do is draw a perpendicular bisector of each of the sides of my triangle. All right? This is a line segment, right? GH. So I'm going to find the midpoint and I'm going to find the perpendicular line. Well, luckily on this program, I got a thing that says what? What's that thing say? Can you read it? Yeah, you can read that. What's it say? Talk to me. Perpendicular bisector. Very good. Okay. So what I'm going to do is just click on this line right here. What do you think it's going to do? It's going to find the midpoint, and then it's going to draw a line that's what? It's perpendicular to it. Okay. So boom, there it is. Now, they drew a line, so it keeps on going. Watch, I can make this smaller, smaller, smaller. What happens to that line? It keeps on going, right? It never stops. I think there's a way to make it into a line segment so it doesn't just keep on going like this. And I just couldn't figure it out this morning. I'm sure there's a way. I think I've done it before. I just can't remember. But we'll just keep the big old line there. It just keeps on going. So that's the perpendicular bisector right here. Now, if you wanted to, we did this, didn't we? Angle with given size. So what do I do? Select the leg point, the vertex. Okay, select. What is it? Select the leg point. This one. Nope, it's not what I wanted. How did I do that before? Find the angle. No, don't want that. Was it just angle? Oh, it wasn't angle with given side. Okay, 3 points or 2 lines. Okay. So if I click this line and then I click this line, boom, there's my 90-degree angle. Would you agree? It's 90 degrees? All right, good. So let's do this a couple more times. Perpendicular bisector of this side, boom, right there. Now watch this. I mean, so far that's been mildly interesting, not really, but I'm not going to put that. Would you agree that that's a right angle? I'm not going to do that for every one of them, but well, I tell you what, let's just do that. Might as well. It doesn't take that much time. Let's do that. Let's do this. Boom. There's your 90-degree right there. And now what we're going to do is do it to the third side. Now, this is kind of cool. Watch. If I click on this, it makes a perpendicular bisector. Let's do that angle thing again. So let's go this and this. All right. So you agree they're all 90-degree angles? Okay. What's really cool, though, is that all 3 lines do what? They intersect each other, right? They intersect each other at one point, all right? So that's kind of neat, I think. I could change this triangle around. Look, it's still going to intersect at one point, no matter what the lengths of the triangles are. These are still perpendicular bisectors, right? That hasn't changed. So I could take this and move it around, right? It's still a perpendicular bisector. Okay, so they meet at this point right there. Guess what we're going to call this point? What's the title of this lesson? The Circumcenter. So I'm just going to change the name of it. Circumcenter. There we go. All right, so that point right there, whoops, that point right there is the what? It's the circumcenter. Just put it about right there. You're like, okay, well, yeah, it's kind of cool if they intersect each other, and no matter how you make this triangle. Remember I said I could have made it an acute triangle, obtuse triangle, or a right triangle? Let's see. Right now, it's a what kind of a triangle do you think? I just got done giving you a list of 3 types of triangles, and you give me something that says isosceles. It's what? Is it obtuse? What is it? It's acute. Yeah, it's an acute triangle. Each one of these angles are acute angles. If I wanted to, I could go through and just tell you what each of the angles are. I'm really not going to do that now. So what I could do is do this. So far it's an acute triangle. Watch this. What if I make it obtuse? Where do you think that circumcenter is going to end up? It's going to be outside the triangle. So check this out. Look, now it's obtuse, isn't it? See how I made this G an obtuse angle? So look where that circumcenter goes. It goes outside of the triangle. What if I made this angle G a right angle? Where do you think that circumcenter is going to end up? It's going to be right on the hypotenuse. There we go. So that's a right angle. It's a right triangle. That circumcenter lies right on the hypotenuse. Okay? So that's kind of interesting. But that's not the coolest part. Let's turn this back into an acute triangle, all right? What the coolest part is this right here, and this is something you're going to have to remember. If I made a line segment from the circumcenter up to each of the vertices, okay, let's do that. Let's go segment, let's click on circumcenter, and then we'll go to F, and I can actually change the color. I'm going to do all 3 of them, then I'll change the color just so it stands out a little bit. All right, and then go from circumcenter to H. See what I'm doing? I'm going from the circumcenter to the vertices of the triangle. And
Is that like the line going down that little strip?
This one right here?
No.
What? Oh, it's because the screen is warped. See, that's all it is. See that?
Oh, yeah.
So if it was real flat, I could just look at it. Does that bother you?
No.
Okay. It does bother you. I could put
I mean, I know
it just on the whiteboard. Would you rather?
it's good now.
All right. Yeah, there's a lot of lines here, but that's what I'm going to do right now. I'm going to color some of these lines. So if I do this, I can make this one red. I'm going to make this one red, just so they pop out a little bit. You're right. There is a bunch of lines there. So I think coloring these right here makes it a little easier to see. Would you agree? Yeah. So look at these red lines right here. Now take a wild guess. It doesn't matter. Watch the red lines. As I move this thing around, what do you think is happening with those red lines? It looks like they're all the same, doesn't it? Is that a guess that you would make? Yeah, it's a guess that I probably would make. All right. Let's find out for sure. How do we find out for sure? We click on distance or length and we click on these lines. So that one's 9.1 right now. Hopefully this one's what? 9.1, and guess what? 9.1. Check it out. There you go. Now, what if I change the triangle shape? Now, it might not be 9.1, but what do you think is true about all the red ones? They should be all the same. So if I move it like this, look, they're all 8.7. Even if I made it an obtuse triangle and the circumcenter is outside the triangle, they're all the same, aren't they? 9.7. If I made it so that it lies right on there, then they're all the same again, all right? So all those red ones are the same. So that's what our theorem says, okay? Our theorem says, let's see, I got it written down here. Instead of going back to that other program, I'll just read it off to you. It says, a point that lies, the perpendicular bisectors of the sides of a triangle, here's a word that I didn't use, are concurrent at the circumcenter. Concurrent means they all meet at one point, okay? So we already talked about that. Would you agree? They all meet at one point. But it goes further than that, okay? So each of these perpendicular bisectors meet at that circumcenter, okay? But what else is true? It also says the point is equidistant from its vertices, okay? So that means that that circumcenter is the same distance to point G, which is a vertex, right? To point F, which is a vertex, and the same distance to point H, which is a vertex. All right, it says it's equidistant, which means it's what? The same distance. Make sense? All right, so that's pretty cool, isn't it? Yeah? Yeah, I like that. Let me show you one other thing. I'm going to zoom out just a little bit. I think I was going to zoom out a little bit. Let's try this again. Control minus, there we go. All right, watch this. This is kind of interesting as well. So I'm going to click circle with center. So what I'm going to do is click on the circumcenter, and then I'm going to extend this out. See how it's making a circle? So what do I call that point where everything's radiating out of as far as a circle is concerned? If you just had a circle, and you had a point right in the middle of the circle, what do we call that? The center of the circle. Very good. Okay, so there's the center of the circle. So the center of the circle is at the what? Circumcenter. Okay, now if I take this all the way out until it hits the vertex, check it out. It doesn't just hit this vertex, but it hits that one and it hits that one, which means that the radius, you know about radius of a circle. We haven't technically talked about circles in here yet, but you know about the radius. What's the radius? The radius is from where? From the center to any point on the circle, correct? So what is true about this red line right here? It's the what of the circle? The radius of the circle. What is this one? That's the radius of the circle. What's that one? That's the radius of the circle, okay? So what has to be true about every single radius of one particular circle? All the radii have to be what? The same, exactly. And it's true. This shows you that they are the same, isn't it? All right? So this is kind of cool because it kind of tells you where the word circumcenter comes from. It's center, but it's not really the center of the triangle, is it? Right? Would you agree? Oops, I didn't want to do that. Watch. It's not really the center of the triangle. Would you agree? It's the center of the what? The circle. That's right. Let's make this a little smaller so we can see the whole circle. Okay? So it's the center of the circle. And circumcenter. What is that reference on on a circle? The circumference, right? The circumference of the circle, okay? So it goes around. See, that circle goes around that triangle. Everybody see it? We say that, here's a math or a geometry word that we're going to use later on, probably not so much right now, but we say that that circle is circumscribed about the triangle, okay? It's circumscribed, which means each point on the triangle lies on the circle itself. Okay? All right, that's a lot of information. Let's do one more thing. So that's circumcenter. So, and you can kind of see what they're going to do with this on the problems eventually, right? I don't think on the first homework they give you any like math stuff to do. They just want you to know, where the circumcenter is. How do you get the circumcenter? By the way, how did we get to that circumcenter? What did I do with that triangle to begin with? I found the what of each side? Found the what? And there it is. It's right in front of you. I found the perpendicular what? Bisectors of each side of this triangle. Oops, I'm getting... Let's move this thing down here. Get that out of the way. There we go. Okay? Do you see that? See those big black lines that are flying all over the place? All right? Those ones right there are your perpendicular bisectors because it split this segment or this side in half and it made a perpendicular line at that midpoint. It did it for all three of those sides. And so they're always going to intersect each other. Where do they intersect each other? At the circumcenter. That's right. Now, what's true about that circumcenter? It's equidistant. The circumcenter is equidistant from the what? From the what of the triangle? What is that of the triangle? Right, but we got three of them, so we don't say vertex, we say from the vertices, right, from the vertices of the triangle. So the circumcenter is equidistant from the three vertices of the triangle. It's a lot of words, a lot of stuff, but I think that makes sense, doesn't it? Yeah. Now, look, if I go down here, I'm not going to have a clean slate because these lines keep on going forever and ever, so I'm just going to clear that, clear all. Not going to save my changes. All right, now I got a clean slate. Now we got one more to do. This one's not quite as exciting, but it's the other word. What's the other word? How do I, what did I do? Went down here, didn't I? Text. Click on that. And what do we call this? Right, Orthocenter. I am. I do every one. Orthocenter. There we go. And I got one more thing. Let's see. Can I copy and paste this? I don't know. Let me right click on it. Duplicate. There we go. Well, thought I was duplicate. Can I click on it? There we go. That's what I was trying to do. Okay, so we're going to find the orthocenter. That's the whole idea of this second part of the lesson. But before we find the orthocenter, what we're going to do is find a thing called the altitude. Okay, now what in the world is an altitude? Well, I'm glad you asked because here's the answer. So let's say this. Here's the example that I always use. I'll make this right there. Altitude. How high it is. Okay, that's good. So like if you're in an airplane, say you're at C is the airplane, okay? Point C is the airplane, and AB is the ground level, all right? You're flying along, right? And the pilot gets on there with his pilot voice. He says, "Oh, welcome everybody," all that kind of. You ever been on an airplane with a pilot, right? He kind of mumbles a little bit, and he's like, "We'll be flying at an altitude of 30,000 feet." What does that mean? The altitude of 30,000 feet. Does it mean from here to there? Is that the 20,000 or 30,000 feet? Is it from there to there? No, where is it? It's from where the airplane is, what? Give me a math word, geometry word. Say it. Perpendicular, right. A lot of people say, oh, it's just straight down. Yeah, I know what you're saying, but let's say it in geometry terms. It's perpendicular to the ground. I got to hit the Alt key to go perpendicular. And then, let's see, boom, right there, okay? So CD is the what of this line segment. It's the altitude, okay? Why is it the altitude? Because it's perpendicular, all right? Does it have to be at the midpoint? No. All right. So we did bisector before, or perpendicular before. This is perpendicular again. All right. So, but it doesn't have to hit at the midpoint. It's just perpendicular to the side. Everybody good? So it's from a point perpendicular to a side. What did we do on the orthos or the circumcenter? We went from the midpoint of a line segment perpendicular to that midpoint, correct? All right. This one, we're going from some point off of the line segment. We're going perpendicular to that line segment. All right. That's altitude. That's altitude. Now what we're going to do is we are going to do orthocenter. So we're going to do this with a triangle. So let's draw another triangle. A, B. Well, it's E, F, G since I already used some letters up there. Oops, it's not what I wanted. Ah, stupid me. Well, that'll bring it back. All right, got to get used to this program. I only use it just a handful of times a year, so there we go. A handful? Well, like 5. I don't know how many exactly. All right, there we go. Let's just make it look. Let's make it look more acute, like that. Okay, so now what do you think we're going to do to all 3 of these sides? We are going to find the altitude, which means, and we got to find the altitude from a point, correct? So from a point. So I want to go from E perpendicular to FG. All right, and I should be able to do that. So if I click perpendicular line, I'm going to click point E, then I'm going to click this line segment down there. Boom, it makes a perpendicular. Okay, everybody see that? Doesn't hit the midpoint, does it? Because it's not the circumcenter. It goes from where? It goes from a vertex, perpendicular to the opposite side. We got it? All right, let's do this one. Let's go from F. We'll go perpendicular over here. So I'll just click on that. Boom, there it is. Perpendicular. It's a right angle. I could put that it's a right angle, but don't want to waste our time. How much time do I have, by the way? 10:30. Oh, I got a good amount of time. Good. So what else are we going to do? We're going to go from G perpendicular to what? EF, right? There it is. Lo and behold, guess what happens to all 3 of those lines? They do what? They intersect. That's right. They intersect at this point right there. And we can name that point. Let's name it. What do you think you're going to call that point? Orthocenter. Very good. All right, so there is our point, the orthocenter. Now, remember on the circumcenter, we had something special about it, right? That circumcenter was equidistant from all 3 vertices. Do you think that's true here? No, from there to there is definitely not the same as from there to there or from there to there, okay? There's really nothing else special about it. Sorry, orthocenter, but you're not that special, all right? So it's really, that's the only thing that you really need to know about orthocenter is how we found the orthocenter. There's nothing, that point right there doesn't mean anything, all right? It's not equidistant to anything. It's not anything. It's nothing special except for the fact that it's concurrent. What did I say concurrent means? They all meet at the what? At the same point, okay? So they all intersect each other, right? All those altitudes, but they intersect each other at the orthocenter. But other than that, that's really the only thing halfway interesting. Let's change the shape of our triangle. Look, it's still acute, still acute, still acute. What happens when we start making it obtuse? Look where that orthocenter ends up. Kind of like the circumcenter, right? Yeah. So it ends up outside of the triangle. Okay, it still exists, but there it goes. And then that's inside. And then what if we made that a right angle? Boom. If that's a right triangle, look where that orthocenter is. It's right there at the right angle. So that's kind of interesting, I guess. A little bit, but there we go. Okay? And that's basically it, I think. Let's do this. Let's go back to that. Why is that not showing up? Oh, I know why. I got to click that. There we go. Okay, so we learned about circumcenter. Oops, my little pad turned off. We learned about the Circumcenter. So without all the pictures and stuff like that, let's review briefly. How did we find the Circumcenter? So how did we find the Circumcenter? What did we have to draw on the triangle? A perpendicular, what? Not just line segment, a what? Bisector. Okay? So we took the perpendicular bisector of each of the what? Sides. Okay? So that's how we found the Circumcenter. Now, what was special about the Circumcenter? Okay, the Circumcenter was what? Equidistant. Oops. That's correct. Equidistant from the three vertices. Okay? So this is how we found it right here. This is how we found the Circumcenter. This is what's special about the Circumcenter. We'll just say that, okay? So we'll say that this is what's special about it. This is how we found it. Now, how did we find the Orthocenter? What did we find from there? We drew an altitude. My little graphics tablet's a little shaky today. Altitude. I don't know if it's because the other program's open or what. The altitude from each what? I should say this. The altitude to the opposite side of each vertex. Okay? I'll just say from each vertex. All right? To the opposite side, if you want to put that in there, however you want to say that. Okay? So from the vertex, you go to the opposite side, perpendicular. Okay? The altitude, yeah. You find the altitude, which means it's perpendicular. Okay? So the altitude from each vertex. So you start at a vertex, you go to the altitude to the opposite side. That's how you find it. There's three of them, right? There's three altitudes because there's three vertices. We got it? So they all meet. They're concurrent. What's special about the Orthocenter? Say it? Well, that's not really special or not special, I guess. What did I say? There's nothing special about the Orthocenter, all right? Except the point is knowing is that they're concurrent. Okay, that's really the only thing special, that all three lines connect at the Orthocenter, all right? So that's, I guess, kind of special. But that's going to happen to all five of these things that we're going to talk about. They all will intersect each other, but there's something else that's a little bit more special than that, all right? In that, well, okay, you could say that if it was a right triangle, it lies right on the right angle. You could say that, but really that's not even that super special. So we'll just say that there's really nothing that special about the Orthocenter, all right? So this is one of the least used things that we're going to do, even though it's the second thing that they give us. Usually, I think out of the other book that I taught, they put the Orthocenter last. So they did the important ones first. I think Circumcenter is pretty important, but we've got some other ones. I think two or three. I can't remember. I should know this off the top of my head. But anyway, we do have a couple more to learn, and we'll do that the next time we teach this. Okay? Everybody with this? All right. That's not too hard, is it? Did you like that program, GeoGebra? Yeah, that was kind of slick, wasn't it? Yeah, instead of just a drawing program, it actually found lengths and all that kind of stuff, which is nice. All right. What did I say your homework was? Just 1 to 7 or something like that? Okay, so let me write it down here. Man, this tablet is really slow today. Wonder if I clicked off of GeoGebra. Wonder if it would act better. So, all right, let's see this. It's not acting much better. Maybe you just have to close it down again. So what is it? Pages 209, 210. 1 to 7. 209. I don't know if it looks like it to you, but it's really dragging. Numbers 1 through 7. There we go. All right, that's the homework. Everybody good? All right.